Okay, here we go. So like I said, we are doing transformation of functions. Okay. Just a minute. Never really liked transformation back in O levels. Well, the good news is it's not the kind of transformation that you did in O levels. It's nothing like that. So, and I don't know if it's easier or more difficult because everybody had like their own opinion about transformation. So anyway, as always, I'll let you guys be the judge. Okay, transformation of functions. Okay, so in O levels, how many transformations? But I've seen your videos, which acha chalo, theek hai, that's great. So in O levels, how many transformations did we have? 4. Okay, can you guys name them? Translation, rotation, enlargement, reflection. Yeah, 4. Translation, rotation, enlargement, reflection. So we had these 4 transformations to deal with. Here we have 3. Okay. Here we have 3 transformations to deal with. So number 1 is translation. Okay, and you can further divide translation into horizontal and vertical. Okay, so right now what we're going to do is we're going to do an overview of every single transformation, and then we're going to do every single one of them in detail. Okay, so you have your horizontal translation. What does that mean? Can anyone explain what I mean when I say horizontal translation? What do you think will happen if you translate something horizontally? That is correct. Okay, so if let's say you have a curve, a quadratic curve, which looks something like this, translating it horizontally means that you move it horizontally. That's it. Okay, could be left, could be right. So this is an example of horizontal translation. Okay, acha, Nahayan, x equals to 0 and y equals to 0, what you're saying is basically reflection. Okay, I think you're mixing it up with reflection. So here. So this is, you can see it's moved horizontally. So this is an example of a horizontal translation. Okay, here's your x-axis, here is your y-axis. Okay, that's okay, nothing to worry about. And then you have your vertical translation. So what will that look like? Sir, is this topic? Yeah, it's a subtopic. It's a subtopic, but it's normally dealt with separately because you won't have the concept of domain range being applied over here or composite functions or inverse being applied over here. Okay, so it's a subtopic, but it's normally dealt with separately. Along y-axis, yeah. So vertical translation basically means that you move it vertically. Okay, so let's say that you have, again, a quadratic curve, something like this. And we have, if you think about it, we have done vertical translation. We might haven't done horizontal translation, but we have done vertical translation. Have we? You guys remember doing vertical translation? Not as formally as we're going to do it now, but we kind of have. Anyone who can give me an example where we did vertical translation? Yes, that's correct, sine x plus 1. So what happened when we had to draw sine x plus 1? We took the graph of sine x and moved it 1 unit up. So that's a good example of vertical translation. Yeah, completing square as well. Okay, but in completing square, we didn't really like see the transformation in action. But when we were sketching trigonometric curves, we could see that, sine x, how was sine x plus 1 different from sine x? It was 1 unit up. And just like that, if you have, let's say, sine x minus 1, how is sine x minus 1 different from your sine x? It's going to be 1 unit below sine x. Okay, so again, this is how trigonometry helps you understand transformation of functions. Okay, so more about this transformation in detail later on. Okay, in fact, we're going to do translation today in detail. Okay, like I said, right now we're just doing an overview of every single transformation. Then you have stretch. Okay, so you have something, you have something called stretch. Okay, and literally what we do is we stretch the function. Okay, so stretch also can be broken down into two. You have your vertical stretch. Okay. No. I don't. Okay, don't confuse this with enlargement. Okay, so when we're all right, let's see how this is different from enlargement. So let's say you take a shape and you enlarge it. Okay, that means you're increasing every side with a certain ratio. Okay, so if you have to enlarge a triangle, that means you're going to increase the base, the perpendicular, the hypotenuse, if it's a 90-degree triangle, okay, by a certain ratio. In stretch, what we do is we either stretch it vertically or we stretch it horizontally. Okay, so yeah, this was out of our syllabus in O levels and IGCSE. Stretch and shear were two transformations that we didn't have in our syllabus back in O levels and IGCSE. Okay. So vertical. But the thing is, vertical is the word that we use ourselves, amongst ourselves, to describe it when we are explaining it or when we are writing it down in the exam. What we use is we use parallel to y-axis. And let's see why this is considered. This kind of stretch is considered parallel to y-axis. And you know what? We have done this as well without realizing. Can anyone give me an example? So I was unable to attend Saturday class. So after watching recording, I have a question. Can square root of x plus 4 be written as... No, you can't do that. You can't do that. Yeah. Range? What do you mean range? 2 sine x is a good example, Moise. 2 sine x is a good example of a vertical stretch. Now, why? Or even 2 cos x for that matter. So let's see what a vertical stretch looks like. Okay, I want you guys to pay close attention. We all know what the graph of cos x looks like. This is what it looks like. So you have 1 and you have minus 1. This is 90. Here we have 180. Here we have 270. And here we have 360. Okay? So what I've drawn in blue is y is equals to cos x. Now what will y equals to cos 2x look like? What will y is equals to cos 2x look like? What's going to happen? Question for you guys. What will y equals to cos 2x look like? Sorry, oh, wait a minute. Sorry, not cos 2x. My bad. 2 cos x. Sorry, not cos 2x, 2 cos x. Yeah, so what will y equals to 2 cos x look like? What's going to happen to all the y values? Chalo, I'll make it easy for you guys. Y values will increase. Okay, so previously we at 0 it was 1. Now it's going to be 2. Okay, at 90 it was 0. This is going to remain 0. At 180 it's minus 1. So this gets multiplied by 2, which means it becomes what? It now becomes minus 2. All right, so here we are. And again, 270 at 0, that point remains as it is. And 360, at 360 it's 1, but now it's going to be 2. So what happens is all the values get multiplied by 2. So if you were to compare y equals to 2 cos x with y is equals to cos x, how would you describe the difference? You would say that the graph of y is equals to 2 cos x is a vertical stretch or is a stretch parallel to the y-axis. Okay, so this is an example of a vertical stretch or a stretch that's parallel to the y-axis. Okay, so again, you can see how doing trigonometry helps you understand these transformations better. Okay, now more about all these transformations in detail later on. Okay, like I said, we're now doing what we're doing right now is just an overview. We're going to do every single transformation in detail later on. All right, now let's say you have a horizontal stretch. So can anyone give me an example of a horizontal stretch? We've done this as well, by the way. Horizontal or parallel to x-axis. Sine 2x, yes, that's a good example. So by the way, when we say stretch, normally you would think that something is going to become longer or wider horizontally, but that's not always the case. You know how when we say enlargement, if you remember, if you go back to O levels, was it possible in enlargement that the image turned out to be smaller than the object? Even though we're saying it's enlargement, but did it happen that the image turned out to be smaller than the object? And when did this happen? Yeah, diminished. ठीक है, but my question is, when did that happen? Minus, no, not minus. Yes, when it was between 0 and 1. Okay, could be positive, could be negative. So if the scale factor was between 0 and 1, the image turned out to be smaller than the object. So just like that, when we say stretch, that doesn't mean that it's always going to get longer and it's always going to get wider. Okay, it's possible that it might even get shorter or it might even get narrower. Okay, so even though it's a stretch, but it might get wider, it might get shorter. And even though it's a stretch, it might get taller or it might get shorter as well. Okay, so keep that in mind. Now let's take an example. Let's say we take a graph of y equals to sine x. So what I'm drawing in blue is the graph of y is equals to sine x. Something that we're all familiar with from 0 to 360. So here's 360, here's 180, here's 90, and in between 180 and 360 we have 270. So here's 1, here's minus 1. Now what will happen if I now draw the graph of y is equals to sine 2x? All the values of x get divided by 2. That means at 0, y is 0. So 0 divided by anything or multiplied by anything will remain as it is. But previously, y equals to sine x was 1 when x was 90. Now it will still be 1, but it will be 1 when x is 45. Previously, it was 0 when x was 180. Now it will still be 0, but it's going to be 0 when x is 90. Okay. And then at 270, it was minus 1. Now it will still be minus 1, but it's going to happen at half of 270. That means at 135. And previously at 360, it was 0. Now it will still be 0, but it's going to be 0 at 180 degrees. So that means this is what we're going to end up with. And you can see that what this is basically a horizontal stretch or a stretch that is parallel to the x-axis. Okay? Again, more about this later. Like I said, I want you guys to keep one thing in mind right now, and that is we're just doing an overview of every single transformation. Then we're going to look at them in detail. Okay? Then we have the third and the final, which is, yeah, sine 2x doesn't look like a stretch because when we think of stretch, we think, yeah, it's a shrink, exactly. Because when we think of stretch, we think that it's going to get wider. Okay, just like, you know how when we think of enlargement, normally you would think that the image is going to be bigger than the object because the word enlargement means that you're taking something and you're increasing it. So here, when we say stretch, that doesn't mean that it's always going to get wider if it's along the x-axis and it's always going to get taller if it's along the y-axis. No. In a stretch, it could always get narrower or it could shrink. And at the same time, it could also get shorter if it's parallel to the y-axis. Okay, all that depends on the scale factor, and more about that later. Okay. Then we have the third and the final. Anybody wants to take a guess? Perhaps the easiest. Reflection. That's correct. Okay, so we have reflection. Now there are two types of reflection. What are they? You have one which is along the x-axis. Okay. So you can please explain. ठीक है Janat, I can do that. Not a problem. And then you have another reflection which is along the y-axis. Okay. So I'm trying to squeeze everything on the same page. Let's see if I can do that. Yeah. So along x-axis, what happens when you reflect something along the x-axis? What do you guys remember? If you remember anything at all. So let's say this is a graph. Okay, doesn't matter what this is the graph of, but x values stay the same, y changes, all right? And what's the change exactly? The change is that all the y values get multiplied by the sign changes, basically. So if they're positive, they become negative. If they're negative, they become positive. Okay, so you multiply all the y values by -1. So this is an example of a reflection along the x-axis. Okay. And then you have a reflection along the y-axis. Let's see what that looks like. So if, let's say, I draw half of the sine curve, okay, and then if I have to reflect it along the y-axis, that means this is now my mirror line or my line of reflection. So the image is going to look something like this. Okay. Now, just so you guys know what happens when you reflect something along the x-axis, is that you multiply the entire function by minus. So what you see in green now is what the reflected curve is going to look like. And here, when you reflect it along the y-axis, this is what it's going to look like. Y equals to f of minus x. More about this later, okay? I don't want you guys to get confused right now. More about this in detail, inshallah, later on. Okay? Now, the two transformations that we don't have in our syllabus is rotation. So I'll just put a cross here. Why is the minus sign outside? Okay, yeah, we will learn this later. Yes, we'll learn this later. Okay, today we're going to focus on translation, inshallah. We're going to do translation in detail. If you're able to finish, then we'll do stretch, and then we'll do reflection. Okay. So the one thing we don't have in our syllabus, the two transformations that we don't have in our syllabus are rotation and enlargement. Okay. So if you ever think that a certain transformation is a rotation, you're probably wrong because we don't have that in our syllabus. Okay. So any questions so far? If yes, please feel free to ask. Okay, great. So now we're gonna dive deeper into translation. Okay, like I said, we have done an overview of every single transformation. Now we're gonna do translation in detail. Okay, first we're gonna look at the graphical side of things. Okay, we're gonna see what happens graphically when you translate something. Okay, and this is something that we know already. Can you move the slide up? Yeah, sure. Here you go. Take a screenshot or copy it, do whatever. Let me know when you're done. Okay, great. So, what is a translation defined by? That was for rotation. That symbol was for rotation. Okay. Moving units, okay, but there's something that you define it by. Like, for example, rotation is defined by the center of rotation, the angle, the direction. Enlargement is defined by scale factor. Vector, yeah, that's correct. So basically, it is defined by the vector. You can say column vector, or you can say matrix, doesn't matter. But what does the vector look like? It looks like this, AB. Okay. Now the question is, what's A and what's B? So A decides how much the curve or the shape, whatever, is going to move horizontally. Okay. So A decides how much your curve, normally we're going to be dealing with curves, okay, is going to move horizontally. So if it's positive, it's going to move towards the right. If it's negative, it's going to move towards the left. Okay, quite understandable. And then B, on the other hand, decides how much it's going to move vertically. So if it's positive, it's going to move up. If it's negative, it's going to move down. Okay. So let's do an example to further understand this. Let's say that you're asked, let me write this down. Let's say that you're asked to translate the following. Translate the following graph of y equals to x square by the vector. And let's say there are two parts to this. Let's say in the first part, you have to use the vector 2, 1. Okay, so this is part A. And let's say there's a part B to this where you have to use the vector -3, -1. Okay, so what we're going to do is we're going to be slightly lazy about this, and I'll tell you what I mean by that. So we're going to draw ourselves y equals to x square using Desmos. Okay. Yeah, here we go. Let's take a screenshot. Okay. Now 2, 1. Translating it by the vector 2, 1. What do you think will happen if I do that? If I translate it using the vector 2, 1, what do you think will happen? Like, describe the movement to me. Can you do that? 1 up. All right, good job. 2 units right and 1 unit up. That's correct. Okay, so I'm going to do this using the color blue. Again, I'm just going to be a bit lazy about it. I'm just going to trace over it so I don't have to draw the curve myself. So this is the original curve. All right. Now translating it to 1 by the vector 2 1 means, so we're not looking at the equation right now. Okay, that part comes later. So this is the graphical side of things, Moise. We're gonna see what happens to the equation later on. So here's the original curve. Translating it 2 units right means this is what it's going to look like, and then 1 unit up means this is what it's going to look like. Okay, and there you go. That's it. Job done. So we're just gonna erase the excess part. And here we go. Okay, now let's see point by point what has happened. So this point, which was initially at 0, 0, now you can see has moved 2 units to the right and it has moved 1 unit up. Okay, let's take another point that we can see clearly. Let's take this one. This point has moved 2 units right and 1 unit up. And just like that, this point also has moved 2 units right and 1 unit up. Okay, so pretty understandable. Now what about part B? What's going to happen in part B? Minus 3, minus 1. What are we going to do now? Graphically, okay? Don't worry about what the equation will look like. Let's see the graphical side of things first. Minus 3 means, yep, it's going to move 3 units left and 1 unit down. That's correct. So, oops. So here is, wait a minute. Yeah, so here's the original curve. Take a. Minus 3 means it's going to move 3 units to the left, and negative 1 means it's going to move 1 unit down. And let me change the color to green. Okay, and you can see that every point moves 3 units to the left and 1 unit down. Okay. All right, so the graphical side of things is not that difficult. All right, this is the easy part. The challenging part is basically where you have to come up with the equation. Okay, which is what we're going to do right now. We're going to see what happens to the equation after you translate it. Okay, but any questions so far? Any questions regarding what we have done? Please feel free to ask. Okay, great. Now, before we see what happens to the equation, again, let's just play around a little. So we have y is equals to x squared. In fact, let's write it as f of x, although it makes no difference, but let's just do it for the sake of it. F of x. Okay, so we have y equals to f of x squared. All right, now what I want you guys to do is, I want you guys to observe a pattern. All right, so here we have y equals to x squared, and in it, I'm going to add a. Okay, now what's a? We'll play around with the value of a. In fact, wait a minute, not like this. Here, yeah, so we have f of x equals x square plus a. Yeah, there we go. Okay. So when a is 0, like for example here, so both the graphs are basically overlapping, okay? One is on top of the other. Now what happens as the value of a increases? Again, this is something that we're familiar with, but we're just doing it formally for this, just for the sake of understanding the concept. But as a increases, what happens? What change do we see? We see a vertical change. So if you have a as 3, that means if it's x squared plus, no, it's not shrinking. Okay, it's not shrinking. All right, you might think it's shrinking because it's moving up, but it's not shrinking. Okay, the only thing that's going on is that it's either moving up or down. Okay, it's being translated vertically. All right, the width remains the same. Okay, the width of the graph, the height of the graph, everything remains the same. So as a is positive, as a becomes more and more positive, what happens? The graph keeps moving more and more upwards. And as a becomes more and more negative, that means the graph moves more and more downwards. Okay, so here you have x squared minus 5. As you can see, as I keep on decreasing the value of a moves more and more downwards. Yes, exactly. So if we subtract, the graph moves downwards. If we add, the graph moves upwards. Okay, so I repeat, if we subtract, the graph moves downwards, and if we add, the graph moves upwards. But the question is, where do we add and subtract? We add and subtract towards the end of the equation. Okay, towards the end of the equation. So f of x equals to x squared. That's where it ends. So towards the end of the equation, if I add, the graph moves up. If I subtract, the graph moves down. Okay, so let's write this down. Let's write this relationship down so that we don't forget. Okay, so I want you guys to pay close attention to what I'm saying. So we're looking at vertical translation right now. Okay, so we're looking at vertical translation. So let's say that we start off with y equals to x square. So what does the graph of y equals to x square looks like? We just saw this is what it looks like. Here it is. Okay. So what I've drawn in blue is f of x. When I say y equals to x square, or if I say f of x equals to x square, I don't want you guys to get confused. They both mean the same thing. Okay. So this is the graph of y is equals to f of x equals to x square. Now what happens if I have to draw f of x equals to x square plus 2? The only difference there will be is that this graph is now going to move 2 units up. Okay, so what you see now in green is the graph of f of x equals to x square plus 2. Okay, now what about if I have to draw f of x equals to x square minus 2? What's going to happen now? Now the same graph will move 2 unit down. Okay, so there you go. What you see in red is the graph of f of x equals to x square minus 2. Okay? Now let's generalize things, because it's very important for us to generalize and see what will happen if we add or subtract something in the equation. So the general way to explain this is this. I want you guys to pay close attention. Sir, could the number added to x square be considered the y-intercept? Yeah, exactly, because if x becomes 0, what happens? The number that you're left with at the end is the y-intercept. Okay, so when you have just x square, what's the y-intercept? It's 0. When you have x square plus 2, what's the y-intercept? It's 2. And when you have x square minus 2, what's the y-intercept? It's minus 2. Okay, so what you pointed out is absolutely correct. So as I was saying, let's generalize this. The graph of y is equals to f of x plus or minus a is a translation of y is equals to f of x by the vector. Now what's the vector? Since it's only a vertical translation, that means x is 0 and y is a. And a could be positive a if it's moving up, and it could be negative a if it's going down. Okay? So I'll repeat. The graph of y is equals to f of x plus or minus a is a translation of y is equals to f of x by the vector 0 plus minus a. Now, this doesn't mean that it's always going to be, it's going to be plus as well as minus. It could be plus, it could be minus. Okay, so if it's moving up, it's plus. If it's moving down, it's minus. That's how we decide. Okay? So this is your vertical translation. Again, as always, take a good look at it. Let me know if you have any questions. All right, now let's see horizontal translation in detail. And this is where things get slightly tricky. Okay, only tricky at first. Once you understand what's going on, then it's not that difficult. So with horizontal translation, it's the other way around. Let's start with f of x equals to x square. Okay, and now let's see what happens if we have f of x equals to x. In fact, let's make a bracket, x minus 2, bracket close, the whole thing square. Okay, now observe the two graphs and tell me what's happened. So what we have done is, in horizontal translation, we have subtracted something from x. Okay, now observe the 2 and tell me what's happened. It's moved 2 units to the right. Okay, so when we subtracted 2 from x, the graph has now moved 2 units towards the right. Okay, now following the same pattern, if I subtract 3, it's going to move 3 units to the right. If I subtract 4, it's going to move 4 units towards the right. If I subtract 5, it's going to move 5 units towards the right. Okay, so let's bring this back to 2. So when I subtract 2, the graph moves 2 units towards the right. Acha. Ab ek kaam karte hain. Let's do one thing. Instead of subtracting 2, now let's add 2. What do you think will happen if I add 2? Okay, let me change the color of this. Let me see if I can do that. Just a second. Okay, great. It's a different color now. Yeah. Sorry, x plus 2. Yeah, here we go. So now that I've added 2, the graph has moved towards the left. Okay, so this is the tricky part. With y, it's straightforward. When you add, it moves up. When you subtract, it moves down. With horizontal translation, it's the other way around. Now, when you add something, it moves to the left. Okay? And when you subtract something, it moves towards the right. Now, any idea why that is? Think about it. Why do you think that is? Completing square. What do you mean by completing square? Maybe what you're thinking is correct, but you're not able to explain it correctly. All right, anyone else? Is it because negative value becomes positive after you square it, leading to 9? No, that's not the reason. X is along 0, so positive moves left. Yeah, that's what my question is. Why is that the case? Why is it that when I add something, 9 doesn't have anything to do with expansion? We take turning point from completing square when x minus 2. Okay, so we're following the same rule here. You're right. Okay, you're right. We're following the same rule here. Like for example, if I want to find out the turning point over here, it's going to be 2 comma 0. So you can see that. If I want to find out the turning point over here, it's going to be minus 2 comma 0. But the question is, why is that? You move the negative value to the other side to add your value. Yeah, I think you're onto something. So think about it this way. If let's say you have to find out the x-intercept, what are you going to do if you have to find out the x-intercept? For any curve, line, doesn't matter whether it's trigonometric, exponential, make y 0, okay? So when you make y 0, and then when you solve x plus 2, the whole thing square equals to 0, what is the value of x that you get? Your x-intercept will then turn out to be minus 2, okay? And then here, if you have to find out the y-intercept, that means again, the x-intercept, sorry. That means you will again make y equals to 0. And then when you solve for the x-intercept, you will get x equals to 2. Why? Because in order to find out the value of x, whatever constant you will have to move it to the other side. And when you move it to the other side, the plus becomes minus, the minus becomes plus, which is why we see what we see. Yes, we're making y equals to 0 to find the value of x. Okay, we're making y equals to 0 to find the value of x. And it's not just y equals to 0. Okay, it's not just y equals to 0. Take any y value for that matter. Let's say we take this y value where y is 4. Okay, so if I want to find out what the x value is when y is 4, so I will plug in 4 in place of y. Okay, and then when I solve it, I will have to take this positive 2 across the equals to sign to make x the subject. And then when I take the positive 2 across the equals to sign to solve for the value of x, what's going to happen? It's going to become minus 2. So that means adding something to x will eventually lead to it being subtracted from the value that's across the equals to sign. Okay, and just like that, subtracting something from x will eventually lead to this same value being added to the y value across the equals to sign, which is why the change that we see is opposite. Okay, so this is just something that you guys, it's good to know. Otherwise, you can, at the end of the day, you can always memorize that, when you add, it moves towards the left. When you subtract, it moves towards the right. Okay, but it's always a good idea to know why it is what it is. Okay, so let's write this down. Okay, let's write this down so we don't forget. Yeah, this is kind of like, kind of, not entirely. Okay, so let's say we have f of x equals to x square. All right, so here we have f of x equals to x square. Again, I'm just going to be a bit lazy about this. I'm just going to copy it from here, not draw it again. So this is what it looks like. Here's the x-axis, here's the y-axis. Now, if I want to draw f of x equals to x minus 2 the whole thing square, what's going to happen is that the graph will move 2 units towards the right. So that means the new graph is going to look something like this. Let me change the color. There you go. And then similarly, if I want to draw f of x equals to x plus 2 the whole thing square, that means now the graph will move 2 units towards the left, and it's going to look something like this. Let me change the color. There you go. And this is minus 2. Okay. So if it was f of, yeah, it's the same thing. Because eventually, how would you find f of x minus 2? Okay. Achha, not f of x minus 2 equals to x squared. If it was f of x minus 2, that means you're going to plug in x minus 2 in place of x. Okay, so for example, if let's say the question gave you f of x and now it's asking you to find out or draw f of x minus 2, that means now you have to move it 2 units towards the right. Okay. Okay, let's write this down. Let's write this down. The graph of y is equals to f of x minus a is the translation. Now don't worry, I know it's getting confusing. It does get confusing, but I have a summary, basically, what do you call? A cheat sheet, you can say, which you can refer to over and over again and clear your doubt, okay, if you ever get stuck. F of x minus a is the translation of y is equals to f of x by the vector. Now, since we're subtracting something, let's say, let's make a note here that a is a positive constant. Okay, since we're subtracting something, where is the graph moving? When we subtract something, where is the graph moving? It's moving towards the right. So what will the vector look like? If a is a positive constant and we subtract a, or like for example, if a is 3, so what will the vector look like? I'll give you guys two options. Will it be 3, 0 or will it be minus 3, 0? 3, 0. Okay. So if a is positive, now when I say a is positive, that doesn't mean that here you will have plus a. A is positive means that it's not going to happen that a will have a minus sign of its own and then eventually it's going to become plus. A is positive means that a could be 1, 2, 3. The minus sign will remain as it is. So the vector is going to be a 0. And just like that, the graph of y is equals to f of x plus a. Yeah, someone saying something? Is
there like a connection between the a in the equation and the a in the vector?
yeah, they're the same. They are the same.
So they are the same thing. Like
Yeah.
when one changes, the other also changes.
Yeah, because whatever it is, see, here. If let's say I ask you to give me the vector which describes the translation which takes the blue graph to the green graph. So how would you describe it using the vector? You can see that there's a horizontal change of 2, and because it's positive, so what will the vector be? In fact, let's write it down, chalo, now that you've mentioned it. If I want to write down the vector which describes this graph, what will it be? 2, 0. Okay, so when you subtract something, okay, even though you're subtracting, this is the technical part, even though you're subtracting, but what is happening due to that? The graph is moving towards the right, which is why when you're writing down the vector, you write the positive value. And just like that, if I ask you to explain it to me in vector terms, if I ask you to give me the vector which takes the blue graph to the red graph, because it's moving leftwards, it's going to be minus 2, 0. Okay? Getting my point? Don't worry about it. I will write it down. I'll make a table which will help you guys understand and remember everything that we have done. Okay, but right now, take a good look at it. Let me know if you have any questions. Okay, brilliant. I see no questions. So this is your cheat sheet. Okay, what I'm going to make now is a cheat sheet which you can refer to again and again if you ever get stuck. Okay. So yeah, sure. There you go. Okay, brilliant. Acha, so here is the cheat sheet. I want you guys to keep this safe, keep it with you. If you ever get stuck, you can always refer to this. Okay. So here we have y is equals to f of x. Okay. In this column, we will write down the vector, and in the column next to it, we will write down a description. Okay. And in the column next to it, this is something new. We will write down the translated point. So if you have a point x comma y, we'll see what the impact will be on that point when it goes through that translation. Okay. So let's start by f of x plus a. Okay. So how would you describe it since we're adding something? Okay. And remember, a is a positive constant. Okay. So because of this, the graph moves a units up. Okay. So the graph is going to move a units up. And how would you describe it using the vector? It's going to be 0, a. Okay. And what will the translated point look like? There will be no change in x, okay, but the y coordinate, the new y coordinate will be y plus a. As you can see, it's like, think of it this way. I'm sure you guys remember matrix addition. Well, O-level students might remember it, but take x comma y and in it add 0a. So x remains as it is, but the new y coordinate becomes y plus a. Now, can you guys do the same for y's f of x minus a? Can you tell me what the vector will look like? Can you describe it? And can you tell me the translated point? Let's start with the vector. Who can tell me what the vector will look like? 0 minus a, good job. And the description, where does it go? A units down, good job. A units down. And what about the translated point? X, y minus a, good job. Okay. Now, as far as vertical translation is concerned, it's usually pretty straightforward because when you add, it moves up. When you subtract, it goes down. It's horizontal translation that can be sometimes a pain. So x minus a. So x minus a, you might want to describe it first. Okay, x minus a means that it's going to move a units to the right. And then maybe you can write down the matrix, which means it's going to be positive a and then 0. Okay. All right, what about the rotated, sorry, not the rotated, the translated point? It's going to be x plus a, because how do you get an x coordinate to move towards the right? You add something to it. And then the y coordinate remains the same. Okay. And then the last, y is equals to f of x plus a. Over here, it's going to move a units to the left. Okay. And then you can write down the vector. It's going to be minus a 0. And what will the point look like? It's going to look like x minus a, comma, y. That's it. Okay. You can refer to this over and over again if you get stuck. So we've seen what happens graphically. We've seen what happens to the equation. And that's all there is. Okay. As far as translation is concerned, that's all there is. What we're going to do now is we're going to solve some questions. Okay. So if you have any questions so far, please feel free to ask. Okay, great. So I've taken out some questions for you guys. Not some, in fact, I've taken out lots and lots of questions for you guys. Let's do them one by one. Okay. So what about a mix between horizontal and vertical translation? Okay, don't worry about it. Okay, let's learn that through this example only. Okay, just a minute. Don't solve this question. Just give me a minute. Just want to make sure that I've covered everything. Yeah, we've covered everything. as far as translation is concerned. Okay, so let's do this, sir. If we have to multiply, no. Okay, so we haven't done stretch yet. All right, we're not doing everything at once. Like I said, first we're gonna do translation in detail, then we're gonna do stretch in detail, then we're gonna do reflection in detail. And of the three, I think stretch is the most complicated. Now, having said that, that doesn't mean it's difficult, even though it's the most complicated, but in it of itself, it's not that difficult. Okay? So, the graph of y is equals to square root of 2x is translated by the vector minus 5, comma 3. Find the equation of the resulting graph. Now, we all know what's going to happen graphically. Okay? We all know graphically it's going to move 5 units towards the left, and it's going to move 3 units up. Okay? But the question is, how do we find out the equation of the resulting graph? So, if it's minus 5, okay, so if it's minus 5, what happens to x? Whatever is being subtracted, okay, like whatever is your value of x, what are we going to do? We're going to add it, okay? So what graphically, what do you think is happening? Is it moving towards the left or is it moving towards the right? In this case, because of minus 5, where do you think it's going? Is it moving left or is it moving right? It's moving left, okay? And what do we do in x that gets the graph to move towards the left? In the equation, what do we do with x that gets the graph to move towards the left? We add. Good job. Okay, so that means y is equals to 2. Now, what's going to happen to x in it? We're going to add 5. Okay, so that's it. We've taken care of this part. And then we have a plus 3. Okay, so this is your vertical translation. What do we do to the equation that gets the graph to move 3 units up? What are we going to do? We're going to add, that's correct. But the question is, where are we going to add? Are we going to add inside the square root? Are we going to add outside the square root? Yes, it's going to be a plus 3 at the very end. Okay, it's going to be a plus 3 at the very end. And that's it. You can then simplify it. It becomes square root of 2x plus 10 plus 3. Okay, I'll explain this again. Dekho. So basically, let me erase this and let's just do it all over again. You have to find out the equation of the translated graph. Okay, and you're given the vector by which it's being translated. So first of all, let's look at the x component. Yeah, component is the word that I was thinking of. Yeah, if you look at the x component, it's minus 5. Now, because of this minus 5, the graph will move 5 units towards the left. Now, the question is, what happens to the equation when the graph moves 5 units towards the left? What happens to the equation when the graph moves 5 units towards the left? So that means if it's moving a units left, you add a. If it's moving 5 units left, what are you going to do? You're going to add 5. And the question is, where are you going to add 5? You're going to add 5 in x. Okay, so that means the x gets replaced by x plus 5. Okay? And then the graph is also moving 3 units up. How do you get a graph to move up and down? You add or subtract something in y. So how are you going to take care of that? In the end, you're just going to do a plus 3. Okay, that's it. You now have the equation of the translated graph. Okay, let's do another example. Don't worry, we're going to do plenty of examples today. Okay, here it is. And remember, before you say how many marks, oh, these are questions from the book. If you had a question like this in the exam, I think it's going to be at max 2 marks, not more than that. Okay. The graph of y is equals to x squared plus 5x is translated 2 units towards the right. So that means 2, 0. Find the equation of the resulting graph. Give your answer in the form of y is equals to ax squared plus bx plus c. Now, yes, I know it's 2 marks are very less, but a question like this will be of 2 marks. There are more extensive questions of transformation in the exam. You'll come across in past papers. Okay. Here. So how do you get a graph to move 2 units towards the right? What should you do to the equation? Or to x in particular? So that it moves 2 units towards the right. Subtract. That's correct. So that means what we're going to do is, that means in the equation, x will then become x minus 2. In the equation, x will become x minus 2. So x squared will now be x minus 2 whole square. And since you have x in multiple places, make sure that you change all the x's to x minus 2. Okay, and can I leave it over here? Well, no, I can't, because the question has a specific requirement. So if the question has a specific requirement, we have to fulfill it to get full marks. So x squared minus 4x plus 4 plus 5x minus 10 And now you have x squared plus x minus 6 as your answer. Okay? That's it. That's your answer. So what we have done so far is we've seen the graphical side of things. We've seen what happens to the equation. And in these two examples, we were given to find out the equation of the resulting graph. What do you think could be a possibility? Like, there's another possibility that a question might test you on. There's another variation to this. What do you think that can be? Think about it. It's not something that you will have to think. Okay, obviously, when you look at the question, you'll realize. But think about it. Reverse. Okay, elaborate. Yes, you might have to find out the real equation. And, there's another variation. You may be given the original equation. Okay, so they've already made you do that. They've already made you find out the transformed equation. It's possible that you may have to find out the equation before the original equation, and it's also possible you're given the original equation and you're given the transformed equation, and you have to find out the vector. Yes, Rij. They might even make you find out the vector. Okay, and that's what we're going to do now. That is exactly what we are going to do now. Okay, no, wait a minute. That's not exactly what we're going to do now. Since I've done the first two examples, I would like you guys to do these examples yourself without my help and do all of them. Okay, do all of them because they're not going to take you very long. And don't simplify. Okay, don't simplify. Just leave it as it is. Like, for example, here, 0, 4, just write plus 4 here. There's nothing you can do over here anyway. But in the ones where you can simplify, don't simplify. Okay. So I'll give you guys 5 minutes for this. I hope you guys have taken a screenshot of this. And if you have, just keep referring to it. Also, how will you do that? Khair. Let me see if I can put both of them in one frame. Okay, here you go. You have everything you need in one frame. I'll be back on my desk in 2 minutes. Okay? Good luck. Anyone would like to give me the answer to part A? You can unmute your mic and then answer if you find it difficult to type. Yeah, that is correct. That is correct. Y equals to 2x squared plus 4. Again, because it's a vertical translation, things are pretty straightforward. Okay, what about part B? That's correct. Y equals to 5 root x minus 2. Okay, root over of... Acha, theek hai. Then, what about part C? Again, pretty straightforward. Plus 1. Yeah, Moise plus 1. Okay, good job, Momin. All right, what about part D? Again, I think pretty straightforward. It's going to be y is equals to x square plus 1. Because you'll have minus 2 and then minus 1 and then plus 2. So it's going to become y is equals to x square plus 1. Okay. All right, now, part E. What do you say? 2 upon x plus 5. Good job. So because it's minus 5, that means the graph has to move towards the left. How do you get a graph to move towards the left? What do you do to the equation? You subtract. You add 5. Okay. Okay, then part F, again, pretty straightforward. X over x plus 1 and then plus 3. If you've taken the LCM, that's fine. Okay, like I said, you don't have to simplify, but if you've done that, that's great. Nothing to worry about. Oh no, wait a minute. What have I done? Sorry. I translated it vertically. Incorrect. So it's going to be x minus 3. Yeah, it's horizontal. Plus, x minus 3 in the numerator. And then in the denominator, it's going to be x minus 3 plus 1. Yeah, this is correct. Thank you. Moise, your answer is correct. And Wasi, thank you for pointing that out. X minus 3 over x minus 2 if you simplify. Okay. Now, what about part G? Yeah, that's correct. X plus 1, the whole thing square, plus x plus 1. Okay? And then, of course, you can simplify it if you want. Okay? All right, part H. 3x minus 2, the whole thing square, minus 2 plus 3, which then eventually becomes plus 1. Okay, great. So just make a standard rule that with x, if you're given the vector, you're going to do the opposite. Okay, now that you know why we do what we do, now you can set these standard rules for yourself. So if you're given the vector with x, you're going to do the opposite. So for example, if it's plus, you're going to do minus. If it's minus, you're going to do plus. And with y, you do as it is. It's exactly like how we take the coordinates of the turning point. We change the sign of the x coordinate and the y coordinate we take as it is. And now we know the reason behind that. Okay. Acha. So yeah, that's that. So now we're going to look into, now we're going to see, we will have to write down, in fact, what is the translation. Okay, we'll have to find out the translation vector. Okay, now I'll do a couple of examples because so that you guys learn how to figure out how to distinguish. Okay, like it's easy to identify a vertical translation, but again, it can be challenging to identify a horizontal translation. So here's an example: y equals to x squared plus 5x minus 2, and then you have y equals to x squared plus 5x plus 2. Okay, see if you guys can give this a shot. It's not that difficult, to be honest. What do you think is the translation that takes this graph to this? 0, 4, that's correct. Okay, why? Because all you have to do in order to turn this equation into this is add 4. Okay, so technically what you're looking at is you have x squared here, you have x squared here, you have 5x here, you have 5x here, you have plus 2 here, and you have minus 2 originally, and then you have plus 2 in the translated graph. So how do you get minus 2 to turn into plus 2? Well, you have to add 4 to it. Okay, so the answer to part A is pretty straightforward. It's 0, 4. Okay. Now let's do part B. Part B is also pretty straightforward. If you think about it, you have x cubed, you have 2x squared. Okay, no change there. Plus 1 all of a sudden has turned into minus 4. So how do you take 1 and bring it down to minus 4? You subtract 5. Okay, so that means it's 0, minus 5. Okay. All right, part C. In part C, you have x squared, which has now all of a sudden become x plus 1, the whole thing squared. You have minus 3x, which has now become x plus 1. So basically, in part C, x has turned into x plus 1. So what do you think? Because of the plus 1, the graph is going to move 1 unit towards the left. Okay, this is what your thought process should be. You're adding 1. What will be the impact of adding 1 to the graph? It's going to move 1 unit towards the left. How do you write it down? How do you write the translation vector for that? It's going to be minus 1, 0. Okay, so now see if you guys can try part D, E, and F yourself without 2, 0 for part D. That's correct. Good job. Part D is 2, 0. Because its x has turned into x minus 2, that means the graph is going to move 2, 0, 0, minus 2. Okay, you might want to rethink that. You might want to think about what you're saying, 0, minus 2. No, it's not even 0, 2. Okay, had it been 0, minus 2, the minus 2 would have been at the very end. Okay, had it been 0, minus 2, or had it been 0, 2, the plus 2 would have been at the very end. You can't simplify the plus 2 from outside the square root with the expression that you have inside the square root. You can't do that. Okay, like for example, over here, yeah, the 3 remained as it is. Okay, you can't bring this 3 inside the square root. Doesn't make sense. Okay, so you might want to rethink. 2, 0, all right. Why is that? Why is that? 4, 0. No, it's not 4, 0. Yes. Yes. So I'll solve part E, okay, because it's a bit technical. So here it is. Pay close attention. So what you're thinking about is this. Your job is to somehow turn this 5 into 3. Okay, and the way to do that is by subtracting subtracting 2 from inside the square root. Okay, so the way to turn this 5 into this is by subtracting 2 from inside the square root. Okay, now what can I do now? Is there a way to rewrite this? Let's see. So how about I write it like this: 2x minus 2 plus 5. Okay, and then how about x minus 1 plus 5? What do you think? Now can you tell me what the answer is? And by the way, minus 20 is also incorrect. Now what do you think the answer is?
1 5.
It's not 1 5. We haven't translated it vertically. It's 1 0. Yes, it's 1 0. The correct answer is 1 0. I'll explain it again. So first of all, narrow it down to whether it's a horizontal translation or a vertical translation. Okay, narrow it down to that. We know that it's a horizontal translation. Okay. So because it's a horizontal translation, that means something has to be done to x. Okay, something has to be added or subtracted. So how did I narrow it down that it's not a vertical translation? There's nothing that you see outside of the square root that's being added or subtracted. Okay, whatever has happened inside the square root. That's how we got this 5 to turn into 3. Now the question is, how do you turn 5 into 3? Well, you can do that by simply subtracting 2. Okay, and because of this 2 being subtracted, again, this does not mean that it's a vertical translation, because a vertical translation would have meant that you have the minus 2 outside the square root. Okay, now what can you do with this expression? So you can clearly see what the transformation is. You can rearrange it. You can write 2x minus 2 plus 5. Okay, and then you can take 2 common. When you take 2 common, you can clearly see that you have x minus 1 inside the bracket. And now you can see what the translation is. Because you've subtracted 1 from x, that means it's going to move 1 unit towards the right, which means it's 1 0. Okay? So, all good now? What about part F? See if you guys can do part F. Part F is also a bit technical, okay? Take your time, don't rush into it. Shouldn't it be 1.5 comma 0? What part, Moise? Part E. Why would it be 1.5? So you're saying if I take 2 common here, you get x. No. You're not. Okay. So your job right now is not to take 2 common as a whole. Your job is to basically see what has happened to x. Okay, that's what your job is. Your job is basically to see what has been added to x or subtracted. So this 5 remains as it is. Okay, because you've subtracted 2 from 5, which is why this has turned into 3. Now what you have to see is that what horizontal translation does this result into. Okay, so for that, what you do is you bring the 2 with 2x, and then you take 2 common. Okay, you have to make sure that whatever change is being done is done to x only. Okay, the change should not happen to 5 or to outside the square root. 2 6. No, 2 6 is not the correct answer. The correct answer is, let me see if 2 4. Good job. 2 4 is the correct answer. Okay, so I'll do it. So in part F, you can clearly see that there is a horizontal translation. Okay, so you can clearly see that there is a horizontal translation because your x square has turned into x minus 2. So let's see what happens if I translate it horizontally. Okay, so this becomes 5 over x minus 2, the whole thing square. So what I'm doing right now is I'm applying the translation 2 0. Okay, this is what I'm doing. X minus 2, the whole thing square, minus 3 into x minus 2. And then if you simplify this, this is what you observe. X minus 2, the whole thing square, minus 3x plus 6. But the actual answer is 5 over x minus 2, the whole thing square, minus 3x plus 10. Okay, that means this must undergo some other transformation as well. What is that transformation? How do you get the 6 to turn into 10? You add 4. Okay, so that means this goes another transformation, which is translation to be precise, 0, 4. And then the final answer, the combined answer, is going to be 2, 4. Okay, all good now? Okay. All right, now. So these are some very easy questions. I initially planned on giving these questions to you guys as homework, but I think we can do them right now. Okay. Wait a minute. Okay. A cubic graph has the equation so and so. Write in similar form the equation of the graph after a translation of 2, 0. Okay. So 2, 0 means the graph is going to move 2 units towards the right. How do you get a graph to move 2 units towards the right? What do you do to x? You subtract 2 from it. Okay. So can you tell me what the final answer is going to look like? I'll give you guys 2 minutes because this requires a bit of simplification. So go ahead, tell me the final answer of this part. And then, you know what? I'll give you guys 5 minutes. I want you guys to do these three questions. Okay? Take your time, take 5 minutes, do these 3 questions. Okay, since you've given the answer, let's see if it's correct. Yeah, that's correct. So it's going to be y is equals to x plus 1 into x minus 4 into x minus 7. And I hope everyone understands why this is the correct answer. So basically what you're doing is you're replacing x with x minus 2. Only the x part. So you're replacing x with x minus 2. That means you have x minus 2 and then the plus 3. You have x minus 2 and then the minus 2. You have x minus 2 and then the minus 5. Okay, that's what you're doing. That's why you end up with what we end up with. So go ahead, do question number 6 and go ahead, do question number 7. And that will be the end of today's class. So here we go. Y is equals to x minus 1 the whole thing square minus 4 into x minus 1 plus 1 and then a plus 2 at the end. Okay, because you have to translate it horizontally as well as vertically. So then expand and simplify. You have x square minus 2x plus 1 minus 4x plus 4 plus 1 plus 2. So you have x square minus 6x. 4 plus 1 is 5. 5 plus 2 is 7. 7 plus 1 is 8. There you go. Okay, now see if you can do question number 7. If you can, that means you're really street smart. So x minus 1 the whole thing square minus 4x. Yeah, that's also... No, wait a minute. You also have to change x from 4x to x minus 1, Moise. See, when you're translating it horizontally, all the x's change. So if x has to change to x minus 1, then the x of 4x will also change to x minus 1. Okay, you get what I'm saying? All right. 2x square minus 19x plus 35 2x square minus 3x plus 23. Nope, wrong. Wrong. Sorry, both of you are wrong. I hope you guys are reading the question carefully. No, Moise, that's also incorrect. Okay, let me know when you guys give up. A is 2, alright. ठीक है, A is 2, that's correct. No, I'm afraid not. B is not minus 11. How can B be minus 11? It's already minus 11. B is minus 3. That is correct. C is not 45. It's not 23. Nope. Not 45, not negative 3. Oh, sorry, not 23. Nope, not even 13. No, not even 9. Nope, not even 15. It's 1. It is 1. Good job, Ryan. 8 minus 22 plus 15. Yep, it's 1. Okay, I'll solve it. So I'm just curious, what did you guys do? Like, how did you solve it? We forgot the 4. Okay. Reverse. Yeah, exactly. Good. Okay. So think about it this way. Let's say you have f of x, which is ax square plus bx plus c. Okay. So here's question 7. And then you have g of x, which is 2x square minus 11x plus 10. Okay. Now, if let's say f of x has to go through a certain translation, which is 2 comma negative 5, and then as a result you get g of x, what should you do to g of x so that you go back to f of x? What should you do to g of x so that you go back to f of x? What translation should we make it go through so that we get the original graph? Yep, minus 2, 5. Okay, minus 2, 5. So I hope this is the critical part. Okay, I hope everyone understands what I'm doing here. It's like if you go back to the very first example here, not the very first, but yeah. If let's say I ask you to take this graph from part A and take it back to the original graph. So how did we get this graph in the first place? We got it by translating it by 2, 1. If I want to take this graph back to the original graph, what will I do? I'll translate it, but this time I'll do the opposite. I'll do minus 2, minus 1. Okay, I'll get it to move 2 units towards the left and 1 unit down. Okay, exactly the opposite of what we did earlier. So here, this is what we're doing. I hope everyone understands this point, because once you understand this part, then it's fairly easy. Okay, then there's nothing complicated. It's just the algebra that we have to do now. So that means g of x, which is this, should now go through this translation, and then we'll get f of x. Okay, so that's what we're going to do now. So g of x will now be translated using this vector. So minus 2. All right, minus 2 means the graph is going to move 2 units towards the left. How do you get a graph to move 2 units towards the left? You add 2 and x. That means x plus 2, the whole thing square. Okay, and then minus 11. In it also, you will add 2. And then you have the plus 10. And then don't forget that you also have to add 5. So the translations are right here. these are the two translations that we have applied. Faiz, we will start stretch. We'll do stretch in the next class. Okay. So let's simplify this. You have 2x squared plus 4x plus 4, close the bracket, minus 11x minus 22 plus 10 plus 5. So you have 2x squared plus 8x plus 8, negative 11x, negative 22 plus 15. And then if you simplify, you get 2x squared minus 3x plus 1 as your final answer. And now you can see that A is 2, B is negative 3, and C is 1. Okay, so if you realized this is what had to be done, then that's great. That means you've understood the whole concept of translation. Okay, if later on you made some calculation error or something, TK, that's something that you can just be careful and avoid next time. All right, so the main emphasis was realizing that you could do the opposite and get the original curve. Okay, so that's it. That's we're gonna keep it till here only, inshallah. If you guys have any questions, please feel free to ask. If not, then let's call it a day and stop here.
Sir,
Yeah,
so can't we do comparing coefficients?
you can do that. You can do that, but that will make it lengthy. Okay, you can totally do that. It's a good idea. So if you, for example, go ahead with what I've written here, then this is what you're gonna do. You're gonna do a x minus 2 the whole thing square plus b into x minus 2 plus c plus, no, not plus, minus 5. And then you will have to expand, and then you will have to compare coefficients. Okay, you can totally do that. You will get the correct answer. But lengthy ho jayega. Now that I think of it, yeah, I think it will be lengthy. Yeah, not recommended. Okay. All right. So as far as transformation of functions is concerned, I'll stop here. We will inshallah pick this up on Thursday. So take care, everyone. Allah Hafiz.